All right, guys, here we go. Page 17 in your packet. A water tank at Camp Newton holds 1,200 gallons of water at time t equals 0. During the time interval from 0 to 18 hours, water is pumped into the tank at a rate of, we have this function, WT. That's the water going into the tank, okay? This is how the AP test would give it to you. However, when you're putting it on your calculator, I typed it out for you exactly the way it should be in your calculator. Now, during the same time interval, water is removed from the tank at this rate. So there's our out. Once again, this is how you will see it, but you need to recognize that when you have signs squared, you need to write all of that in parentheses and square the whole thing. Let's go ahead and put these in the calculator. So I'm going to y equals, I'm going to do WT, 95 square root of x, big parentheses, sine, x divided by 6. Close the parentheses for the x over 6, close them again for the whole sine function. We're squaring all of that. For r of t, 275, parentheses go around the sine as well as around the x divided by 3. Close them, square. Now I know I have to adjust my window. So this is the standard window that I have. Because my domain is 0 to 18 hours for t, I'm going to go just a little bit past that. Let's say 0 to 20. And let's see here, for the y's, this is talking about 1,200 gallons of water as the initial amount in the tank. So I'm thinking we need some big numbers. Maybe let's try 100, see what happens. And as you know, my super cool calculator is a little slower at the graphing, but we'll see. Okay, so here's y1. Looks like we need to go a little bit higher on the graph. Ooh, a lot higher. Okay, this isn't horrible. If your calculators are done graphing, then I would go ahead and change the window. I would have the y max go a little bit higher because I want to know what's going on at the top of the graph here. All right, so I'm going to go back into my window. Maybe I'm going to go up to about 500. Let's see if that works. Okay, the graph looks pretty, but it is a little slow. This is the rate that the water is being pumped into the tank. And now the red graph is the rate at which the water is being removed from the tank. While that's graphing, let's go ahead and look at question A. Is the amount of water in the tank increasing at t equals 15? Why or why not? Now if you want, go ahead, hit pause, and see if you can get an answer for this question on your own. What I want to do is I want to look after 15, hours, I'm going to go trace 15 and see what happens. So when t equals 15, that's where I am, that's the rate going in, this is the rate going out. So which is higher, which is faster? The rate going out. So if we think about the water tank as the overall picture, we have water going out very, very quickly and only a little bit is going in. Therefore, the overall effect that the water in the tank is not increasing. So let's write that down. The water is not increasing because R of 15 is greater than W of 15. The rate of the water going out is greater than the rate of the water going in after 15 hours. Okay, hopefully you got that. Part B, to the nearest whole number, how many gallons of water are in the tank after 18 hours? Go ahead, pause the video, and see if you can come up with an answer. What I'm looking at, how many gallons are in the tank after 18 hours? The gallons after 18 hours, I have to think about how much water was in the tank to begin with, which we know was 1,200. Plus, since I want to know how many gallons are in the tank now, I need to add up, which is integrate, from 0 to 18. I'm adding up all the water going into the tank, and I'm subtracting all the water coming out of the tank. So here's my work that I'm going to show. And now back to the calculator. In Y3, I'm going to do Y1 minus Y2. Using my vars key, I'll input my functions. And then I'm going to go up and turn off y1 and y2. I don't want those on. I just want to look at that graph right there, y1 minus y2. So I'll take a look at that graph and I'll integrate that graph from 0 to 18. It looks like the graph is below the x-axis down here, so that's okay though. As long as I have 0 to 18 on my x-axis, I'll be able to integrate this. Let's see. When you're ready, we're going to do second trace. Option 7, my lower limit is 0. My upper limit is 18. And it's shading the area underneath the graph. You can see it working a little bit just at the very bottom of my screen. And then if you remember, as soon as you get an answer on here, we're going to add 1200 to it. So I've got 109.788. I'm going to add 1200 to that integral. And check your units on this to the nearest whole number. So I'm going to round that. So I've got 1,310 gallons of water. So that's my answer for part B. All right, not too bad. Now, part C. At what time from 0 to 18 is the amount of water in the tank at an absolute minimum? All right, so here's what I need to do. If this formula in part B is showing me how to find the amount of water in the tank, I want this to be a minimum. So I want this derivative to equal 0 or DNE and have a sign change negative to positive. So if I look at this, I want the gallons prime to equal 0 DNE and have a sign change negative to positive. Okay, now this doesn't ask me for a justification, so I don't need to be super specific with that. Now, if I take the derivative of this formula, take the derivative of this, I've got this. Now, if I take the derivative of 1200, I'll get 0. If I take the derivative of an integral, I'm just going to be left with my function. So what I'm looking at is w of t minus r of t. So what I want to know is when does w minus r equal 0 or DNE? So I'm going to make a number line here from 0 to 18, and I'm going to do w minus r. That's the number line I'm looking at. I want to know when w minus r is 0 or DNE. If I go back to my graph, this is w minus r. I want to look at everything under the x-axis. I need to look at when this graph is 0. Therefore, let's see, I want to go to the window, and I want to see some of that area below the x-axis. So I'm going to change that to a negative 200, see if that works. And when I look at this, this is w minus r that's being graphed. So when does this function equal 0? At your x-intercepts. So I need to find that x-intercept. So when this is done graphing, I'll be able to get that answer, put that on my number line, then we can check the sign change. Okay. Second trace, option 0. I want to find these x-intercepts, so I'm just going to scroll. Let's see here. And I've got one x-intercept at 6.495, so I'll write that down. And I have another x-intercept over here, 12.975. Okay, so now when I look at this, I want to find out my signs. At first, my graph is below, so it's negative, positive, negative. So now if I'm analyzing this, that means decreasing, increasing, decreasing. Where could I have a possible minimum? I could have a possible minimum at t equals 6.495 or at t equals 18. This is a closed interval. You have to check your endpoints. Now I already know that if t is 18, the amount of gallons in the tank is 1,310. That's from part B. I already know that answer. What I need to figure out, how much water is in the tank after 6.495 hours. So I have to do it all over again. 1200 plus the integral 0, 6.495 of W minus R. I need to get that answer and figure out which one is actually lower. So I need to go back to my graph, integrate from 0 to 6.495. Area under the curve, shading in the region. And once this is done integrating, which it is, I'm going to add 1200 to it, and I've got 525.242. Therefore, what this is telling me is where is my absolute minimum at t equals 6.495. Where can I jump that down? So I'm going to come down here, min at t equals 6.495 hours. There's your answer. Okay, final part, part D. When t is greater than 18, no water is pumped into the tank, but water continues to be removed at the rate of R of t until the tank becomes empty. Let k be the time at which the tank becomes empty. Write, but do not solve, an equation involving an integral that can be used to find the value of k. Here we go. If I want the tank to be empty after 18 hours, well, I know that there's 1,310 gallons in the tank at 18 hours. If I want it to be empty, then that means that is how much water has to be removed. So I need that to equal the integral from 18 to k of R of t. What this is saying, I'm going to add up all the water being removed from 18 to k hours, and when that integral is equal to 1310, that's when the tank will be empty. So it's not that bad. Just set up a little integral equation. We're writing it, we're not solving it. Okay, hope you understand all that. Good luck.